Okay, so in the previous class we have studied the concept of aromaticity and the conditions. Today in this video we are going to see many examples, okay? Examples, I will give you the examples, you just work it out and try to find out the answer for these questions, okay? Okay, for the first, this is the first compound. In this compound, this is cyclic, okay? The first condition is cyclic. Yes, it is cyclic. Then the second condition, it should be planar, right? All the carbon atoms are sp2 hybridized. So, this is planar. Then, of course, next rule is Huckel's rule. Here we have 2 pi electrons, right? Only one bond, so it is 2 pi electrons. Hence, this compound is an aromatic compound, okay? I hope you understood this concept clearly. The next example is, since we have already seen many examples, 3 to 4 examples, I am going somewhat faster, okay? So the second compound, let me give you an example, this one, okay? For this one, is it cyclic? Yeah, it is cyclic. Is it planar? Yeah, it is planar. And count the number of pi electrons. You have to include the negative charge also, because negative charge indicates that it has 2 electrons, right? So, 1 pi bond, which means 2 pi electrons, and the negative charge also 2 electrons, 2 pi electrons. So, totally you have 4 pi electrons. If the number comes out like multiples of 4, then it means this compound is anti-aromatic compound, right? Next one. Let me give you another example like this. Okay? Here, yes, it is cyclic. Is it planar? Just see whether it is planar. Here, these 2 carbon atoms possess sp2 hybridization. But what about this? It has sp3 hybridized carbon. See, you may have this doubt like how you are saying that these 2 are sp2 and the other one is csp hybridization, right? It is very simple. Count the number of sigma bonds or single bonds around the carbon atom, okay? That will provide you the hybridization. For this carbon, what's the valency of carbon? It is 4, okay? For this carbon, here 1 sigma bond and here 1 sigma bond. So 2 sigma bond. Another one is pi bond, right? So don't calculate it. 2 sigma bond. So in order to satisfy the valency, another hydrogen will be there, because carbon has a valency of 4. This one bond, another one, another pi bond is there, and here 4 bonds are there. Among these 4 bonds, you have to take it for consideration only the sigma bonds, right? You shouldn't include the pi bond. So here you have 3 sigma bonds, right? 3 in the sense sp2 hybridization, because of 2 it is sp. Then if it is 3, then it is sp2 hybridization, and hence this particular these 2 carbon atoms possess sp2 hybridization. See, this carbon 1, 2 and 3. So it possesses sp2 hybridization. Similarly here also. But here, see, this is 1 carbon atom. 1 sigma bond, 2 sigma bond. So other 2 will be hydrogen atoms, because it has to satisfy the valency of 4. If it has 2 sigma bonds in the sense, another 2 will be hydrogen. Okay? CH2. So 4 sigma bonds are there. If it is 4 sigma bond, then it is sp3 hybridization. Okay? If it is 2, see, let me give you another example. You will be very clear with the concept of hybridization also. CH triple bond CH. What is this? Acetylene, right? Here, for this carbon atom, if I ask you to calculate the hybridization, just count the number of sigma bonds. It is 1 sigma bond. Here, triple bond means 1 sigma bond and 2 pi bonds, okay? So you just take it in consideration only 1 sigma bond. So 1 sigma bond, another 1 sigma bond. Hence, it is having 2 sigma bonds. If it is having only 2 sigma bonds, then it is sp. Okay? I hope this is clear. So if you have the number of 2 sigma bonds, then that is sp2 hybridization. If it is 3, then sp2. If it is 4, then it is sp3. Okay. Otherwise, you can simply say like if there is no conjugation of pi electrons, it is non-planar or non-aromatic. Okay, because here sigma bond is here. Sorry, double bond is here. Another sigma bond. Here you should have double bond, right? But here there is no double bond. So it is non-planar. The system is possessing sp3 hybridized carbon, and it doesn't have conjugation of pi electrons. Hence, this is said to be non-planar. Of course, it is cyclic, but it is non-planar and it doesn't have conjugation of pi electrons. Hence, this is non-aromatic. This compound is said to be non-aromatic compound. Okay? Okay. So, the next one is for this compound. It is cyclic? Yes. It is planar? Yes, because it possesses charges. Here these 2 carbon atoms has the number of sigma bonds like 1 and 2 and 3. Okay. Similarly 1, 2, 3. Okay. So these 2 carbon atoms possess sp2 hybridization. And similarly here it has charges. For this carbon 1, 2, here 3. Another one is negative charge. Okay. So all the atoms are sp2 hybridized. Hence, this system is also a planar system. Okay. This system is also a planar system. So, it is cyclic, it is planar. Then, count the number of pi electrons. It has 2, 4, 6. Okay. Because you have to include the negative charge and lone pair of electrons while accounting for the aromaticity. So, 6 pi electrons. Hence, this compound is said to be aromatic compound. Okay, so the next example, let me give you another example. Already we have worked it out for benzene, right? So now, what is this compound? This compound is nothing but naphthalene. All the carbon atoms are sp2 hybridized. You would have studied in your UG or during your school days that benzene, naphthalene, anthracene, all these are planar. So planar in the sense all possess sp2 hybridized carbon. So this system is cyclic. Yes. It is planar. Yes, it is planar. And then just count the number of pi electrons. 2, 4, 6, 8, 10. 10 pi electrons. If you are unable to count the number of pi electrons, just count the number of pi bonds. 1, 2, 3, 4, 5. 5 pi bonds. Each bond is nothing but 2 electrons. Hence, you have 10 pi electrons. It is also a Huckel number, right? 2, 6, 10, 14. These are Huckel numbers. So, this compound is also an aromatic compound. Okay. Again, let me give you another example. Anthracene. So, anthracene is again cyclic. Yes. It is planar. Yes. All the carbon atoms are sp2 hybridized. And then count the number of pi bonds. 1, 2, 3, 4, 5, 6, 7. 7 pi bonds, which means it has 14 pi electrons. Then this system is also an aromatic system. Okay. Because if it comes like multiples of 4, then it is anti-aromatic, or it comes like 2, 6, 10, 14, 18. This is said to be aromatic compound. So let me give you another example. And 5-member ring, which is connected to a 7-member ring. Okay, 7-member ring. This system is said to be azulene. Actually, this compound name is azulene. Okay. Here also, all the carbon atoms are sp2 hybridized. Okay. Just see, all the carbon atoms have double bond. The carbon atom has double bond, it possesses sp2 hybridization. If it possesses triple bond, it is sp. If it doesn't have any pi bond, it possesses sp3 hybridization. So here, all the carbon atoms possess double bonds, and hence all are sp2 hybridized, and hence this compound is said to be planar. So it is cyclic, it is planar. Count the number of pi electrons. 1, 2, 3, 4, 5. So 5 pi bonds, which means 10 pi electrons. It is in conjugation, right? Hence, this compound is said to be an aromatic compound. I hope these examples will give you a clear idea about aromaticity. In the next class, we will discuss about the aromaticity of heterocyclic compounds, okay? Because in heterocyclic compounds, it is quite different. For heterocyclic compounds, it is quite different, okay? So I will tell you those concepts in the next video. Stay tuned. Thank you.